Hello friends, this lesson is all about ideal gas equation for various processes. Various processes means constant temperature, constant volume, constant pressure, adiabatic and polytropic. In this particular lesson, I will be telling you the gas equations in these five processes. In the previous lessons, we have discussed the representation of these processes on PV diagram, right? But before proceeding any further, I would like to introduce myself. My name is Harshit Agarwal, graduated from NIT Nagpur in 2008. I have cleared the Indian Engineering Service Examination and GATE examination. I have got the offer letter from most of the Maharatna and Navratna companies. Regarding course fee, as you already know, there is no course fee as such, but you can always contribute whatever you feel like. You can also follow me on the specified link. So to start with, ideal gas equation for various processes. The very first process is the constant volume process. The very first process is constant volume process. We have to find the ideal gas equation for this particular process. See, we already know that the ideal gas equation is equal to PV is equal to MRT. As M is generally constant, R is constant, and what process we are taking is the constant volume process. So V is also constant. That means pressure is directly proportional to temperature. That means I want to also show this particular process on PV diagram. Whenever heat is supplied, temperature is increased. Whenever heat is supplied, temperature is increased. And in this particular constant volume process, pressure is directly proportional to temperature. Whenever heat is supplied, temperature is increased and the pressure is directly proportional to temperature. So this is the final equation for constant volume, that is P2 by P1 is equal to T2 by T1. That is, whenever heat is supplied, temperature is increased, so the pressure is also increased. So upward constant volume is heat supplied and downward constant volume is heat rejected. So on PV diagram, this is the constant volume vertical line. So heat is supplied, temperature is increased, pressure is also increased. So upward vertical line is a heat supplied and downward vertical line is a heat rejection. That is whenever heat is rejected, temperature is decreased, pressure is also decreased. Pressure is directly proportional to temperature. So upward line is a heat supplied and downward line is a heat rejection in constant volume. Second is a constant pressure process. Simple to start with, you as you already know, PV is equal to MRT is the ideal gas equation. M and R are generally constant, and the process which we have taken is a constant pressure. So pressure is also constant, which means volume is directly proportional to temperature. So whenever heat is supplied, temperature is increased, and as the temperature is increased, volume will increase. So representing this particular process, we are representing this particular process on PV diagram. As it is a constant pressure process, you will draw this with the help of vertical line. Now how to mark the direction? So many times question is asked in exam that heat is added at constant pressure. Constant pressure means horizontal line, but you have to mark the arrow as well, whether on right side or left side. Always remember, whenever heat is supplied, the arrow is on the right side, and whenever heat is rejected, the arrow is on the left side. So right side heat supplied is constant pressure, and left side heat rejection is also constant pressure, which is heat rejection. Similarly, in constant volume, upward direction is heat supplied and downward direction is heat rejection. So this is the constant pressure and constant volume. The third process is the isothermal process, which is temperature is equal to constant. As we already know, the ideal gas equation is PV is equal to MRT. M is generally constant, R is constant, temperature is also constant. That means P1 V1 is equal to P2 V2, which is PV is equal to constant. It is as simple as that. You already know the equations for the isothermal. For constant volume, we have written P2 by P1 is equal to T2 by T1. For constant pressure, it is V2 by V1 is equal to T2 by T1. For isothermal, it is PV is equal to constant. We can also write it as P1 V1 equal to P2 V2. The third process is a adiabatic process. As we already know that the adiabatic process equation is PV raised to power gamma is equal to constant. We can also write it as P1 V1 raised to power gamma is equal to P2 V2 raised to power gamma, right? We also know that from ideal gas equation, PV is equal to MRT, which is P is equal to MRT upon V. We know that PV raised to power gamma is equal to constant, replacing P with the help of MRT upon V, which is MR is constant, T upon V into V raised to power gamma is equal to constant. So the equations become T V raised to power gamma minus 1 is equal to C upon MR, which is T V raised to power gamma minus 1 is equal to constant. We can also write it as T1 V1 raised to power gamma minus 1 equal to T2 V2 raised to power gamma minus 1, which is T2 by T1 is equal to P2 by P1 raised to power gamma minus 1 upon gamma. This is valid for adiabatic process. So for adiabatic process, the three important equations are P1 V1 raised to power gamma is equal to P2 V2 raised to power gamma, T1 V1 raised to power gamma minus 1 equal to T2 V2 raised to power gamma minus 1, and T2 by T1 is equal to P2 by P1 raised to power gamma minus 1 upon gamma. These three equations are very important in a diabatic process. I am telling you, these three equations are very important. You have to keep in mind these equations. Lot many numericals will be asked in examination in both in ES as well as GATE related to these equations. So please don't forget these equations. The next is a polytropic process. The results are same as diabatic. See, polytropic और adiabatic इन दोनों के results exactly same है, just you have to replace gamma with n. P1 V1 raised to power n is equal to P2 V2 raised to power n, T1 V1 raised to power n minus 1 equal to T2 V2 raised to power n minus 1, T2 upon T1 is equal to P2 upon P1 raised to power n minus 1 upon n. So ये 5 processes हैं. पांचों प्रोसेस में आइडियल इक्वेशंस हमने देख ली, कांस्टेंट प्रेशर और कांस्टेंट वॉल्यूम के डायरेक्शन देख लिए, टुवर्ड्स राइट, लेफ्ट, अपवर्ड एंड डाउनवर्ड. एंड adiabatic and isothermal I have already explained with the help of slope in my previous lesson. So this is the simple course related to all the 5 processes. We have, first of all, we have calculated the work transfer in closed system, then we have found the work transfer in various processes, then the representation of various processes on PV diagram, then adiabatic and isothermal, and in this particular lesson I have told you the ideal gas equation for various processes. The next lesson is very important because we will be discussing the numericals in the next lesson. So just keep focusing, please go through all 6 lessons twice or thrice so that you can solve the numerical problems easily. Numerical problems are very important. Please go through these all lessons at least twice or thrice. Thanks a lot from my side. This is Harshit Agarwal.